Makes sense.
All right.
Good, good.
So yeah, I'm going to talk about some requirements for advanced track pattern modeling and how that can fit within OpenAccess. And so for kind of the outline, the first thing I want to do is go over the problem statement to explain where this need is coming from. And then I'll introduce some work that we've done recently in the track pattern working group. I'll discuss a little bit of how we're modeling some advanced track pattern features, give an update on progress and future plans, and then summarize. So just to kind of give a little bit of background for folks who don't know very much about track patterns or what this topic's really about. Basically, track patterns are something that kind of can define an expected location for wires within a given design, and that need could arise from design rule requirements, or it could come from just a methodology type thing. So I think most of us probably are aware that when you're in an ASIC design, there's obviously a strict gridding requirement usually as far as methodology is concerned. This does happen also in the custom space quite a bit, especially in the more advanced nodes. And anyway, these track patterns define locations for the wires and the intended widths for the wires on a given track, and sometimes, an indication of what that track is intended for, whether it be a power or ground track or a signal track. And then it kind of goes, it has a period of repetition so that it kind of repeats out throughout the design. Those were kind of the basics. There are some more advanced requirements that are needed in some cases for representing tracks. One requirement is to be able to store these patterns in a centralized location so that designs that need them can pull from that area, as opposed to having fragmented definitions in various locations for a given project. Within custom design especially, there is a need to have the user perhaps maybe use that definition directly, or in some cases derive it or even create their own. So there needs to be flexibility for the user to be able to create their own patterns or modify the patterns, the central patterns. There also needs to be a case where maybe the pattern doesn't apply to the entire block. A lot of times most of the time, if possible, it is nice to have just a global pattern for the design, but many times there need to be regions where different patterns occur. Of course, we need to also specify for the given tracks what the intended wire width is meant for that track. And of course, with multi-pattern technologies, we have these concepts of different colors. Sometimes the tracks need to know what color is intended for that track. If planning ahead of time can kind of help with multi-patterning. And then, of course, the track purpose, like I mentioned earlier, about if the track's intended for power, ground, or signals. There is presently a way to represent track patterns in OpenAccess. It's the OA track pattern class. That class, however, is deficient in many ways for the advanced track pattern modeling that I mentioned before, the needs. What you see in the diagram on the right essentially is what is understood by this track pattern class. So I think you'll notice probably the first thing is you don't see any wires there because there's no intended width built into that. So that's one thing. It's not really centralized. There's not a place to store this in a central place within OpenAccess. You can define it, of course, with the API, but it's up to the application on how to centrally store that outside of OpenAccess. There's no concept of multi-patterning. Actually, I don't think it exists anywhere in OpenAccess, and it doesn't exist here either. There's no way to specify that this track is intended for any given purpose, like a signal or a power or ground. and there's no lateral termination. So the blue lines, which represent the direction of the wires, have no begin or end point to them in the data model. So it's really up to the application to determine what that means, whether it really truly extends to infinite extents, or if you know, it needs to terminate in some other way, but it's not specified in OpenAccess. And finally, the pattern is defined with a simple start and stop, at least in the other direction of the pattern. And in order to create more complicated patterns where you have various widths, you have to interleave several track pattern definitions just to create one pattern. So in this particular example, you know, since the wire widths aren't shown here, you can't really see it, but you may be able to notice that some of those spacings are a little different than others. And in order to achieve that, you have to interleave it and repeat by the period of the entire pattern. So it's quite a bit of a workaround. They can be used with some adjustments, but those adjustments are not universal or interoperable with any other application. So whatever somebody may do to make these things work isn't really going to translate outside of their application. So that was the problem statement. So what we did was we, in early 2015, we started a task force to find with various member companies to discuss these needs. We wanted to make sure that we were aligned on what the requirements were. And in fact, we created an initial specification of how this problem could be solved. This was brought to the OA change team. You know, I wasn't there, but to my understanding, there was not agreement to adopt those features within the core OpenAccess data model. And so the provision for cases like this can be to take this to the ESG and to basically become an OA extension. So that's what happened in late 2015, and we've had working group meetings since then where we refined that specification that the task force originally created, and in fact we started some implementation now, which I'll talk about in a minute. So the diagram on the right again has been updated to kind of represent a little bit more of what these advanced features that we're going to model contain. So I think you can see a little bit more clearly now that obviously the intended wire widths are in place. For multi-pattern technologies, I've shown this with different display colors here. That intention of using a particular color if desired, not always required of course, but if it's needed, that ability is there. And then of course the pattern is irregular and represented as a single unit as opposed to kind of interleaving and working around a limitation. So you can define it as a complete pattern and repeat that pattern either by step or flip in order to extend that across the design. And finally, there's a way to store this pattern either in the OpenAccess technology library or in a given design, where that design could either be used as a template to propagate to other designs, or if a user just wants to create their own pattern and the application supports it, then they can do that and store that in their own design. So this is kind of a use model. It's a little bit of an eye chart here, but in essence, what you see here is on the left, we have two patterns defined centrally. So again, that could be in the OA Tech library or in the design. And then those patterns, and that's referred to as a track pattern def. Of course, this is an OpenAccess extension, as I mentioned, so it has that prefix OAX. And that is, those patterns are shown on the right to be instantiated in a design, and there's two different modes that can be followed. One is a global pattern where it kind of extends throughout the design. There's no explicit bounds in either direction. It's just intended to be infinite in both directions. And then as a region could be then defined with a different pattern instantiated, and that would then be cut out from the global pattern. And you can define, obviously, multiple regions. As far as interoperability, as an OpenAccess extension, this is actually registered as within the implementation as an app def. So you can see on the bottom, whatever application it uses OpenAccess and has this utility available, or sorry, this extension available, they're able to basically communicate with that extension using high-level methods, and of course with the OpenAccess database. And then that extension in turn also interacts with OpenAccess. And so it's intended to be very smooth and integrate very well into an OA-based application. And we're also planning to have OA script extensions to make that available in Perl, Python, Ruby, or Tcl as well. And we're planning kind of a first cut of this before the end of the year, if possible. So just really quickly on the status. So as I mentioned before, we do have bi-weekly working group meetings. There was a period of where we weren't meeting as frequently because of availability, but we are meeting again on a regular basis. The initial code has been written for defining the patterns, and we're currently working on defining the instantiation of that as well right now. And actually, I will be contributing some sample grids and a sample design to use for testing. And so I'll make some. Basically, everything I've shown here is completely fictitious anyway, as far as the designs and grids that we're showing. So something like that will be contributed for testing purposes. We are hoping to get a pre-production release. I'm not sure we would even call it a release, but something that maybe a release candidate for the working group members to look at, kind of a stable snapshot, perhaps test or just review the API and give us any kind of feedback that may be needed. So we'll just kind of put something out there that actually works, and hopefully, once again, get the scripting language interface there as well. That's not too difficult to set up because of the way that it's been established within the OA script realm. It's pretty easy to extend this to.
Now exiting.
Avinash. And then we would like to kind of use the same kind of template that EDA vendors do. They always want to share the most amazing things at DAC, and so we will plan to have a production release by that time frame. So perhaps by April would be a good time to release it, to allow it to be out there and ready to go, so we could discuss this more within the DAC time frame next year. By that time, we hope to have some unit tests in place that have a lot more testing there, and resolve any kind of issues or functionality gaps based on the release candidate. So just real quickly, just to summarize, there is really no, currently there's no OA-based mechanism for representing these advanced track pattern concepts, and because of that, we established this working group and this extension to basically allow these advanced tracks to be represented and interoperable. And we've been doing this since 2015 and made a lot of progress, and we'd love to have you participate if you're interested.
Questions? Questions here on the phone? Don't see any hands up on the phone?
No questions.
I've got one. So if you define multiple local regions, can they be different?
Can the pattern within those local regions be different? Yes.
Okay.
Yes, each instantiation can point to whatever definition. It could be the same definition or it could be different definitions.
Any other questions?